Okay, for the purpose of time, I kind of entered into the video a little bit deeper than normal. But if you're looking at parallel capacitance now, one of the first things you'll note is they're kind of like resistors, but yet opposite. In series capacitance, we had to apply the product over sum. Parallel capacitance, we just add them. So a 20 and a 10 in parallel is a 30. And that's just because this source sees that as one capacitor. It's just the plate spacing, and it's just the way the electrons react to those being in parallel. So it's a simple addition. Not going to use a calculator. 3 plus 6 is 9. There. And it doesn't matter if you have more than 2. You just add them. 3 plus 3 is 9. And it's that simple. Now, capacitive reactance is going to give us this formula here, and we're going to see that it varies with the frequency and the values of those capacitors. That formula for X of C is 1 over 2 pi frequency times capacitance. So we could start with total capacitance, which obviously is 50 microfarads, or we could do the individual capacitance. But we're going to see to get total, we have to take the individuals and do something a little differently in parallel. So let's do each individual. I think that's what NIDA is going to do here. And I wish this calculator would just, I can actually drag it and make it a little smaller. So that's good. Well, I guess that's the smallest she gets here. All right, so let's go ahead and do, remember this 1 over x, this is in scientific view, let's go to standard. This 1 over x just takes whatever is down here and divides it into 1. So I can solve everything down here and then divide it in 1 just by pressing this key. So we know for both the C1 and C2, we're going to do 2 pi times frequency. That's going to be a standard. So 2 pi is 6.28 times 100. I can do that math in my head. It's 628. So basically we take 628 and we multiply it by its capacitive value, the capacitive value of each one of these. Well, remember, these are in units. 0.000030 is the same as 30 microfarad. Because 30 microfarad, the decimal would be right here. 1, 2, 3, 4, 5, 6. That takes us back to farads equals. And if I reciprocate that, there is what I get for X of C1. So let's write that down. We'll come over here, and we'll say, let's try a different color. Let's try yellow. We'll say X, and my pen is not writing. Why is my pen not writing? Let's try this one more time. X of C1 equals 53.08. I'm going to go ahead and write X of C2 equals, and I know, I'll clear my calculator here again. I know that 2 times pi times 100 is 628, and then I got to multiply it by 0.123420. Again, 1, 2, 3, 4, 5, 6, 20 microfarads equals, divide that into 1, 79.62 ohms. So let's write that here, shall we? So 79.62 ohms. I'll try to sneak that in up here too. Now, we're going to find out we just can't add those two and get that value, but let's get there first. Let's see if they came up with the same thing. They did for C1, which was 53.08. They did for C2, which is 79.62. Now, they have to take those values and do the product over the sum. Now, I've told you before, I always prefer the reciprocal, but product over sum works fine. And this is different because they're in parallel. In series, we would have just added those two. Can't do that in a parallel. So, let's do 53. Actually, I'm going to change to a scientific before we even get started. So let's get a scientific. So I'm going to need the parentheses to be able to do the stuff on the bottom. So I'm going to say 53.08 times 79.62, and I'm going to hit equals. So that's these two multiplied together, and that's where they got this value. Then I'm going to say divided by, and I'm going to open a parenthesis. That way whatever I put in here will get performed and added together prior to doing the division. So let's do 53.08 plus 79.62, close parenthesis, equals 31.85 if we round. So let's write that down, shall we? So I'm going to come kind of down here. So far my writing hasn't gotten in the way. Let's see if we can keep it that way. X of CT, and again I apologize for this pen. Me and Ed are still learning one another. 31.85 ohms. So there we have it. So let's move forward. And we got what they did in the previous slide. So now it says we can find the X of CT by simply going ahead and adding them together and getting 50 microfarads and applying that to the 1 over 2 pi F of C. And that's what they're doing here, F of CT, I should say. So if I take 628, which is 2 times pi times 100, times 0.12345 equals, and I don't have the right key because I'm still in scientific, so 0.0314, so I'll have to divide that 1 divided by 0.0314 equals 31.85, which is the same thing I got here. So got the same answer two different ways. That's kind of nice. We can check our work. So now it's asking for the capacitive reactance of this circuit. So let's blow away our writing here. And let's take it step by step. So it's wanting C1 only, so we don't need to do both of them together. So let's just do C1 only. So I'm going to take 6.28, which is 2 pi. I'm going to multiply it times 500. I'm going to multiply it by C1 is 30 microfarad. Now notice the values are the same, but we did increase our frequency, so we're going to get a different answer here. So I'm going to say times 30 microfarad, 0.123430. So let's check it. 1, 2, 3, 4, 5, 6. Yep, that's 30 microfarad. Divide that into 1, we get 10.6. If we don't round any at all, then there's our answer. So now, no surprise, it's going to ask us C2. So we're going to say 6.28 times 500 equals, and we're going to say times 0.000020. And again, 1, 2, 3, 4, 5, 6. That puts us right. Divide that into 1, 15.9. So, and no doubt it's going to ask us total. We can do that easily. 30 and 20 is 50. So 6.28 times 500 equals times 0.12345 and 1, 2, 3, 4, 5, 6. That works out right. Put that, divide that by 1 into 1, I should say. 6.36, if we round up, 6.4. So there's our answer. So, we got it two different ways, and it says, take note, X of C of a 30 at 100 is 53, and at 500 is 10.6. As frequency increases, X of C decreases. So that's inversely proportional there. Okay, so we're doing the individual X of C's. We did it for 30 at 100. We did it for 30 at 500, and we saw that relationship. So sorry, just kind of refreshing my own self as we were coming back. All right, X of C of a 30 is 10.6. X of C of a 20 is 15.9, and both of those are at the same Hertz value. So if we increase capacitance, X of C goes down. If we decrease the capacitance, X of C goes up. So they're inversely proportional. So it all depends on what we're doing there. And if the circuit contains capacitors only,
other circuit values are calculated using Ohm's law. So basically, we just take and do IT, for instance. We get X sub C total and divide that out, and then we can get the individual currents for each one of those by dividing that into 13 volts, our applied voltage here. So we can work that out. Let's work it out with the calculator and make sure they arrived at the correct values. So let's clear our calculator. We know 2 pi is 6.28 times frequency, which is 500, and we'll do C1 first, times 0.000030, and we know that's right because we moved that decimal 6 places. We have arrived. So we've got that. We're going to hit equals, and then we're going to divide that into 1, 10.6. So we got the same value for X of C1 they did. So we're going to take 2 pi again, 6.28, times frequency, which is 500, equals, and times 20 microfarad for C2, 0.123420, and again 36, yep, that checks, equals, divide that into 1, 15.9. So we got the same value for X of C1, X of C2. Now we could do the product over sum, or we could just add these together and do for X of C total. I like adding them together. So 20 and 30 is 50. I can do that in my head. I can take 2 times pi, which is 3.14, which is 6.28, times the 500, equals times 0.123450, and 36 equals, divide that into 1, 6.369. If we round, we go to 6.4, which is what they got. So obviously, to get IT, they just took 13 volts, which is E applied, divided by the X of C total, 6.4, equals 2.03. Same thing here, E of A, 13, divided by X of C1, which was 10.6. Whoops. Okay, tried to pause the video before that sneeze came out. Probably caught part of it, but hey, that's part of doing videos. I'm not going to restart just to record, get out part of the sneeze. Anyway, we did the same thing for X of C1, got the 1.22 amps, which we'd round would be 1.23, but that's fine. That's close enough. Same thing here, 13 volts. X of C2 is 15.9. 0.82 amps. So we arrived at the same values they did just by doing the same math. So here we go, our first challenge. And we're at 13 minutes. No need to bite this one off. Try to hurry through. So I'm going to stop the video for RC parallel, and we'll resume this slide in the next video.